release of Eliza that came out just a couple of weeks ago. We have an expert panel with us today to talk all about this new room engine, what it's about, how it works, what we can use it for. Coming to us from around the world, this panel of experts. Let's start with Mr. Scott Willsallen, coming to us from where? It looks like a bamboo room.
A hotel room in Dubai.
A hotel room in Dubai. So Scott, you're working on a little project there.
A little project, Expo 2020 in 2021 for various COVID reasons.
Understood. And this is a pretty special project that probably takes advantage of some of the room engine enhancements that have come out in the last couple of weeks, I would imagine.
Yeah, it certainly does.
Excellent. Scott, thank you for joining us today. Coming to us from somewhere in London, Fred, where are you exactly? Are you at home? Or are you in the office?
Yeah, hello, Scott. Yes, I'm home, but not very far from the office, so I can always jump back in.
Excellent. And you're responsible for all things algorithm at Eliza headquarters in London. Is that right?
Yeah, I'm in charge of the research and development of all the algorithms or algorithmic side for the immersive part of basically L-Acoustics, the Eliza branch.
Fantastic. And if I recall, you're also a headphone aficionado and a connoisseur of fine wines. So this is a pretty good life you live. Algorithms, headphones, and wine. I think a lot of us on this.
Yeah, you don't need much more.
Yeah, you don't need much more. Excellent. And coming to us from what looks like the lab in Highgate, the office in Highgate, Sylvain. Excellent.
Yeah,
welcome.
Definitely. So
Sylvain, you're in the lab in London, kind of like here. It's a 23.1, if I recall. So we have 18 speakers horizontally, 5 overhead, and of course a subwoofer. You guys have a couple of different work surfaces, from a live console to edit consoles for digital audio workstations. But that's not obviously why we're talking today about the lab here in Westlake or in London. We're talking all about the room engine. And my first question is, what is different, Sylvain, between a room engine and a reverb?
So I would say a room engine is really made on purpose to emulate specific rooms, not something that can be, let's say unnatural, while a reverb engine will have more capabilities to be able to create some unrealistic space just for aesthetic purpose, mostly. So yeah, that's how I would see the difference between these two beasts.
Now, Fred, is there a algorithm difference between this? Is there we're talking about creating a real space or emulating a real space?
Well, typically, yes. Typically, there will be quite some fundamental differences between, let's say, what we call a 3D room engine, let's say, and what a reverb would be typically used more like as an effect. Even though there is some overlap in terms of usage behind the scene, the room engine, as we see it, takes into account the space, so the geometry in some ways, and therefore where the different sounds will be inside it. So we create this common space with the room engine. So that is really a key element that helps give the realism that is unique to that type of algorithm.
Got it. So a reverb is just a sound, but maybe doesn't encompass anything about space directly, versus a room engine thinks about maybe the size of the venue you're using. So I imagine, Scott, that this is a dramatic change as soon as you're doing a show for more than 50 people. Thinking more room engine versus reverb about creating a sound of a space. Is that maybe a good way to put it?
Anywhere that speed of sound is an important factor, and that's geometry.
Got it. So Sylvain, you said something, and I think it was a good word of creating something real versus, I think you said artificial or
unnatural. Artificial.
Yeah, there you go. Unnatural. So I think, of course, of all the sound effects that is in a reverb processor that was created years ago, right? So it's the spring verb, right? That's probably not. I don't know of a room that has that sound.
No. But maybe somewhere in the underground, but otherwise I'm not sure.
Yeah, sure. Or a plate, right? I don't know of any rooms that sound like a plate, but those are real sounds we use for music production, right? For a specific sound or effect with something, and that's very different than the reverberation we get from a natural space, right? Now, are there different types of room engines on the market? Are there different types? How do they differ? I'll throw that to Fred. Are there different types of room engines?
Yeah, I mean, there are very much different ways to approach recreating a space, really an immersive space in a 3D. You may go the kind of brute force way of using convolution reverbs and having an impulse response for all the possible direction in space. That would be a possibility to approach room engines. Or you have what we're doing, which is more a hybrid of algorithmic convolution in some ways, because we put a lot of emphasis, for example, on the controls. But there are others, because also you may use like the ambisonic kind of representation as a way also to save and process the sound also in space, but which also has its own pros and cons.
Got it.
So there are many different ways. Yeah.
Scott, do you see these different types? Do you have different applications you use? Maybe these different types, that brute force model. So as I understand it, Fred, the brute force is I go into a real space, I actually capture the sound of a real space, and then I recreate the real space somewhere else. Is that a good summary of that?
Sorry, you're asking. Who are you asking?
Fred. Sorry. I of course, my bad. So, Fred, is the brute force method the acquisition of the sound of a space? So I go to some venue and actually measure what that room sounds like. Is that what you're referring to?
Yeah, absolutely. Which is an interesting process for some types of application, with the drawback of having a lot of rigidity in that process, because you capture once, one day, and that's it. And the freedom you have to later on modify, tweak, and let's say adapt to what you want to do, is then a bit limited.
Got it. And Scott, do you have a use case where one is preferred over the other, that maybe that brute force model versus an algorithmic style?
I don't. The question's difficult to ask because I don't think the question's quite right. With all due respect, the problem is: are we talking about tonality or are we talking about the implementation in 3 dimensions?
Got it.
So the tonality is with capturing an impulse response, you get the time domain, and you can adjust the tonality to some extent, but you can't change decay rates and you can't change anything of that impulse response. It's what it is. Something that's more algorithmic, there's more adjustments available to you, especially in the time domain. And that's all very interesting in creating the right kind of tonality so that the sound of the reverb is nice, is pleasing for what you're trying to achieve. And we've had good reverbs for a while. That's not a new thing.
Yep.
The thing that's new is a reverb that's spatially aware of the space in which it's being used. So if we think of a typical reverb usage, it's a channel or a stereo return of something that you send it comes back. Great, brilliant. But then how you deploy that in a way that respects speed of sound is something that a room engine brings, well, a proper room engine brings that a simple reverb processor doesn't, unless you get quite surgical with how you use that reverb processor, which can be quite, there's a lot of trial and error in that and a lot of mathematics that a great room engine will deal with that for you so that at no point are you hearing any reverb before the direct sound. And I've tripped myself up on that before in outdoor events where we've tried to introduce using standard convolution reverbs to introduce an acoustic ceiling to an outdoor venue, and then having to multiple copies of that same audio with different latencies so that it's sort of the reverb is traveling through the room. So you can do that with convolution reverbs, but there's a lot of surgery involved. A room engine just takes care of it.
Okay, so, and I understand your point. A regular reverb versus a room engine both sound great. And we've had great sounding reverbs for a long time. And we've also come accustomed to certain sounds of certain reverb processors over the years. But the challenge now is if I'm using a reverb processor to create a room sound, I have to be cognizant of making sure that processor is delayed so that when I'm sitting in the back of the venue, I hear the direct energy first, like the real world would happen. Then I hear the reverberant field. That's the
but it only has a context in an immersive environment.
Sure.
If it's just a big PA, it's all coming out the same things anyway.
It doesn't matter. Oh, that's right. So if it's a left right or a left center right stereo a frontal PA only, it's not that big of a deal because the direct sound,
it's all coming from the same spot,
and the reverb comes from the same spot, so I don't have to worry about that. But now if I have surrounds and overheads, it's much more of a concern, especially if it's a larger venue. I'd imagine the surgery you're calculating is an Excel sheet of doom plus.
I mean, it's pretty simple multiplication, but obviously there's a lot of work to be done to lay those tracks out, to try and add a little bit of what might happen tonally as that energy passes through a room. Because like Sylvain mentioned right at the start, this is about being realistic. It's not about exaggerating.
Sure.
Because, we know what exaggerated reverbs sound like. They're great, but that's not simulating a room. That's something very different.
Sure. That's interesting. Now, you mentioned you've had some experience with this, and in the last couple of years, we've spent a lot of effort on the room engine being spatially aware, right? And this latest update is not just spatially aware, but sonically, flexibility and different aspects that enhance the sound of the space. Has that changed your actual workflow, or has it just accelerated the process from A to B?
Yeah, it's made it much easier. It's allowed us to concentrate on the tonality and know that the time domain is in good hands.
Right, and so you're spending less time on the mechanics and just more time on.
Exactly.
Yeah, that's great. Right, that's what you want of any tool, is to not have to think about the basic math, I guess, as you put it.
Is it helpful to illustrate this with the one I made the mistakes on?
Sure. I mean, that's always fun for everyone to realize that even the best sound designer in the world,
we all make mistakes. Every day is a school day.
Yeah,
so
exactly.
the stage, obviously, the chairs are all pointing at the stage. It's not in shot, but these wire ropes are overhead. And when we first started using this system, it was early days of Elisa. There was a reverb, but it was more for I guess theatrical use. So if a performer moves upstage, a little bit of the top end drops away and some reverb gets added. No spatial awareness at all. So we used reverbs from the studio, and initially just used one, I think a 7.1 that was sent to us from the studio, and we placed the 7.1 around in these overheads. And standing sort of down the front there, it sounded lovely. But as you move towards the back, it was very clear that the reverb was early. And then we started to think, well, okay, it's a bit patchy anyway because of the loudspeaker quantity. So let's add another 7.1, or basically copy those tracks again and again and again, and then lay them out down the room, and then add some latency just on simple propagation. And then it worked really well. The reverb sounded good. It took a bit of time. It took a bit of massaging, sure, but it was a great outcome.
Sure. And this probably wasn't too painful. As you said, it's just, these speakers are 10 meters further back. We need to add 10 meters of delay.
Yeah.
That's not hard math. But of course, it would have been challenging if the object you were rendering was in the back all of a sudden, because you would have had to do all of this in reverse then, right?
Yeah, exactly.
And then if you had something moving around the room, well, that would have just...
And we just didn't use reverbs on things that were moving because it was too hard.
Yeah, sure. And Fred, that's different in the Elisa room engine because it's actually aware of the space of each object. Is that correct?
Yeah, absolutely. The way, a bit in a nutshell, the way it works in the Elisa engine is each sound object is encoded in this kind of spatially aware bus, if you want, that retains that kind of direction. And we use that information of direction and position and knowing the speaker layout to make sure that things remain in order, which is very important indeed, and helps so that you can move your object and you are sure that wherever it is, you will still get things in the right order.
So Sylvain, that means if I understand what was just said, it's aware of the speaker layout. So if we actually start in pre-production in the studio and we start building some concept room sounds for a given moment in time, once I get on site, we load the new speaker layout and it's spatially aware and applies any propagation changes that need to happen for that particular layout. Is that correct?
Yes, with certain limitation, of course. If you are in a very small space when you are doing your pre-production and you are still emulating a space that's quite small, of course, if you start to scale it at a very high level, you will not be able to really emulate this space that was really smaller. So you have to adapt a bit to what this gigantic size, I would say, if we look at Scott's projects, would look like. So yeah, it works. Of course, it's really the optic of this reverb. But of course, you have to be realistic, and you cannot emulate 400 cubic meters room in a space like Scott is using.
Yeah. Okay. So I can make it's not really possible to make a room sound of a small space in a large venue because, of course, the reflections would have to arrive before they could even get there. But it is possible to make a small space sound big. So as long as I'm cognizant of that, I can think in pre-production of whether I'm in a Lisa studio on headphones or maybe in the lab in London or Westlake. I can realize this is a big space. We have to be cognizant of that. We can't make a big space feel small per se, but we can play within those limitations. That's interesting. So the algorithm is aware of the object position. It renders that to the space given the speaker layout. And as the speaker layout gets bigger, it correctly applies the latency needed for the room engine.
Indeed.
In all those positions.
Yeah, it will try to match as close as possible to what you want, but giving indeed like the laws of physics.
Yeah, sure. So physics has laws and not suggestions is what a friend of mine says a lot. And I think that's great, right? So it is, I think, about 330 meters a second, give or take a few, depending on, by Scott, it might be a little faster, I think. Is it when it's that hot and dry?
Not dry.
Not dry. Oh, all right.
No, quite humid at the moment.
Oh, that's good. So you actually have high end in the PA. That's nice. Out here in California, we are challenged by the dryness. So that's always the fun part. So, all right. So the room engine we have is spatially aware. That's great. It's not a measurement of an actual space. So it's a recreation of that in algorithm. So that means, of course, we can modify the sound for the venue we're in. So I'll throw this to you, Scott. How does the room engine use change based on the sound of the space? Like, what do you have to think differently when you're in a venue?
I think it's easier for me in that probably just over half of the project we do are outdoor venues. So the tonality of a space is less of a factor for us because we are outdoors. So we get to create our own. Okay. To take this into an indoor context, that's, I think, where the tonality of the space, the natural tonality of the space, is something you would need to be aware of and adjust the time domain within the reverb engine to suit.
Got it. So outside, you can kind of create what you want. You don't have to worry so much. There aren't many or
You're not adding to an existing room tone or an existing sound. It's pretty, there'll be some specular reflections. There's no reverberation.
Sure. And versus when you're doing a show inside, there's already an inherent amount of room sound, obviously. So now we have to add to it. Does that change, Sylvain, the way you might use the presets, right? They're obviously built for an anechoic space. Are they built for a live space? How does that change?
Yes, so as you said, they are not built in purpose for anechoic space, but yes, we are trying to we have tried to achieve a preset that is the most neutral possible. So that would work. That would achieve a good compromise between headphones and very dry venue, or even in a free field. So of course, then you would have to tweak your reverb depending on what the room is already providing. And this is where, once again, it's very useful to go the algorithm way instead of convolution, because you can really get rid of some property of the reverb if they are already present in the room. Let's say if the room is already providing a lot of early reflections or cluster, if we need to explain maybe what the cluster is a bit later on. Or if you have a late that's maybe a bit too sharp, in the way it stops, you can, let's say, smoothen a bit the way the reverb would behave. So it's very flexible to shape and to add to an existing acoustics in a venue.
Got it. So as the sound designer, as the operator, I can choose to modify the room engine to fit within the space I'm at. So if the venue, I think of, my background is more large format touring. So I know, Scott, you've done some of these shows in an arena with an orchestra. Is you probably don't need to add much late to the room. I would imagine that's probably well handled, but it might not be tonally very well behaved, right? So that might be more of the change that wants to happen. Is that maybe correct to think?
Yeah, that's a good way to think it through. Often the venues we find ourselves in double as sports venues, or they're not necessarily good auditoria with nice soft furnishings. So that sort of late, the tonality of the late and the duration of the late changes quite significantly from venue to venue, especially in the high frequencies.
Sure. Right. So a venue might have a long late time, but it might be quite dark or dull in one space. And I would imagine it even changes from sound check in that sports venue to showtime when you add 20,000 sonic absorbers. I would imagine that has a pretty big impact. Now, Fred, I want to go to you real quick because Sylvain said something, and we keep talking about late and early and cluster. Myself, this Scott is not a proficient user of mini reverb, so I'm not familiar with all of these terms. Can you kind of maybe elaborate on what those components of the room engine are?
Yeah, so most people are familiar, of course, with the first reflections and the late reverberation. First reflection, of course, being the first tap that will arrive to the ears, created by, of course, reflections on the nearby surfaces, and they tend to be blended perceptually with the source. The late part is really when the sound becomes completely diffuse. It's a stochastic, it's a random process, and tends to be very then decorrelated from the source itself. And in between, that's a bit the gray zone, and that's where the cluster comes in. That's when the reflections, the density of reflections start to build up. And the way it builds up depends on the space. So the rate at which it builds up depends on the space. And what we do in the new ELISA engine with the cluster processing is we represent, in an algorithmic way, we represent the way this buildup, let's say, happens depending on the room size. So and there has been papers in the literature that have demonstrated that this is quite important in the perception of space, which means like even sometimes we feel like to give the impression of a big space, you need a lot of reverberation or late reverberation. But actually those intermediate cluster taps, if you want, they play a very important role, and they have the benefit to not drown sometimes too much the sound into the late reverb, but yet give the sensation of space. So that's a bit in a nutshell. I'm not sure if it's super clear.
Obviously I've spent the last few months really getting to know the ELISA room engine. So in my mind, I think of, if I was in a concert hall, the early is the reflection that's directly off that stage space right next to the performer. Mm-hmm. The cluster is all the reflections off the room, but yet not just the energy of the space, right? Yeah. And then the late is that decay and energy of the space. Is that maybe a good way to put it? So now we can independently control the reflection that comes from around the performer, the reflection that is from the space, and then the energy of the spaces as a whole.
Yes.
Okay.
Yeah. And for us, it was really important. We are talking about adapting to a different space. And what we wanted to do is make sure the controls are very independent between those three different sections.
Got it.
Because sometimes for example, in a reverb engine, you have the early feeding into the late. So you're controlling one and you're changing a bit the other one at the same time. And that's what we wanted to avoid, so that you can really fine tune like your recipe very well and very efficiently, like all those three sections, depending on your needs.
So speaking of recipe, Sylvain, we've got 36 presets that have been pre-built. Is that correct?
37 if we count the dry preset, but
So,
I'm not sure this one.
No one's counting.
Per preset. you
Yeah,
see.
exactly. No one's counting. It's 37. Fair enough. That's good. So that's like on the console when they count the 2-track input return as a set of inputs, right? It's just not quite fair. So 37 presets. Thanks for the update there. So I think you had a really interesting thing you said to me the other day, which was what's neat about the presets in the Room Engine is obviously there's 4 primary categories, which is a definition of the space, and then we can control the size and the tonality. So you have 3 choices of size, 3 choices of tonality. So the first time I did the math, I forgot how multiplication works, and it's 4 times 3 times 3, as opposed to 4 times 3 plus 3. So that's 36. But you said something interesting, which was it's in the Eliza Room Engine, it's always possible to make one sound like another. So you can start with any preset and modify to end up at any other. It's not limited. There's no difference in algorithm for any of this, correct?
Yeah, it's all these presets. They are just setting suggestions. They are not. They are, let's say, starting point for you to start to build your sound. But there is no like secret settings in the backend that would make this different sound inherently different. It's the same. We are starting from the same reverb shape, let's say, and from there we can really tweak the sound very deeply with the parameters that are completely open to the user.
Got it.
That was really something that we wanted to keep. At some point, we were hesitating. Maybe we should try to have a different recipe for different sounds, but we thought that it was a lot more powerful to have a single sound that you can tweak, let's say, to the infinite.
Sure. And there's 14 different parameters to control, categorized for tone, space, and time. Is that our scenario?
Yeah, and gain as well,
And
because of these different sections.
Right, so we can actually turn up and down different sections. Scott, is there an application where we might, turn up and down different sections, or I believe there's even the option now to send to only certain portions of the Room Engine as well. Is that something that makes sense from a natural scenario, or is it kind of an unnatural maybe setup you might use that as a sound designer?
I can see some applications for some other stuff that I'm not sure we're allowed to talk about, which seem like a very obvious usage for these for these different elements of the these different components of the Reverb engine. To be honest, I don't. I mean, these are creative tools as much as they are anything else. Right. This is about locking yourself up for a few days with some tracks and just using it a lot and understanding how best to implement these different parameters for different instruments for different applications. It's Sylvain used the word infinite in his description of the number of variables that are achievable with all of the parameters. And I think as much as anything else, the power is in your hands. It's about understanding the tool. So by me saying one thing or another, I'm only giving you my examples based upon my use cases, and which are quite limited compared to someone that is touring a rock show and entering a different venue, a few times a week. That would be a really interesting case to sort of dig into how effectively the different elements of that can be quickly modified to suit that fast changeover between venues. I'm quite lucky in that I'm usually in these venues for a really long time, so we can spend loads of time getting this sort of stuff right and experimenting and making loads of mistakes and figuring out what works best for us.
Well, and that's interesting what you just said is obviously and I find this interesting is that the same tool, designed for the infinite number of options that Scott, you can play with at your project, yet is quick enough, Sylvain, that we can easily make a couple modifications for the show today, right? I think of, it feels like last year, but it was probably 2 years ago now when Mark Knopfler started touring. That was, Sylvain, you were the first 4 or 5 shows out there, and it was a different arena every day. And I'm imagining that was a big change every day just from the sound of the space. And yet now the engineering staff, the front of house engineer and the systems engineer can adjust maybe the amplitude of the different sections of the room engine to quickly get that preset to be close, right? And that's something that can happen in a few minutes. Scott, you said something, and whether we talk about it or not, I think it's interesting. In the ELISA controller software, you can send an object to the early module, the cluster module, or the late module, or all three, and you can also choose to send it to direct reproduction or not. So we can say just come out of the reverb engine only and not the room. I think of that from a theater sound design background that I have a little bit in. I can have a duplicate object of the actor and then their room engine sound, and I could imagine having that either be with them or programmed maybe not with them, and that could give a really haunting feeling if their reverb sound was coming from a different part of the room than they were actually coming from. I think that could be maybe a bit of a mind twist to everybody.
Quite a powerful creative tool as much as anything else, and it's all about spending time with it.
Yeah, absolutely. Absolutely. Now, Scott, I know you had a really key thing that you mentioned a couple of days ago when we were chatting about in the room engine, there's a master level, which can be hugely powerful from show to show, day to day, preset to preset. I think that was something that was really important to you.
I think it was me sort of imagining the life of a touring mix engineer, trying to make it great every single night and entering a new venue. And it's my idea of a complete nightmare, but somehow these people enter these rooms that maybe if they're lucky they've been into before, but often not. Often sports venues with loads of concrete and glass, sometimes auditoria with carpet and soft furnishings, and trying to make a great sound with a PA that goes in and tuned before lunch, doors open at, it's crazy. I don't understand how it works. But what did occur to me, just sort of looking through the application, was that overall level control for the room engine, and I thought that's a very, very smart way of being able to lock in your show very quickly in a way that doesn't change any of the really important stuff you spent weeks programming.
Sure.
It could be a really good way to solve some problems very quickly.
In the key there's Sylvain, there's a master reverb fader, right? So there's a master room engine fader, and that's...
Should we show it? It might be worth showing.
Yeah, Sylvain, okay. You want to pop that up?
And the thing I like about it is that it doesn't recall with the snapshots. I think that's a very good thing.
Yeah, right. It's a strong feeling that we had during the development. First, this reverb fader was a part of the presets, and because maybe we didn't really think about it, and first time we tried the prototype, it was not working. We really felt that we needed to separate this fader because of exactly of what you are describing. So that's why we have put the fader here. Can you see only the app or?
Mm-hmm. Yeah.
Oh, okay, good.
Yeah.
So we have put this fader here. You can see that it's really at the far left of the controller. So it's really obvious that it's not part of everything that's on the right, which are reverb presets. So that will be recallable. So that you will need to change one by one if you want to modify something. So really, the workflow is very simple. Let's say when you were pre-producing, you created your presets at a nominal level. Here we call the nominal level. Let's say the reference level for us is -10. So you would start working on -10, and then from one day to another, if you are entering in a venue that is maybe too dry, you would just push that fader, or if it's too wet, you would just pull that fader, and that would be all.
And then that, of course, is independent of the snapshot. So song to song, room engine setting to room engine setting, because a snapshot in ELISA can recall, of course, object position, but it can also recall room engine settings. That -4 dB that you applied in soundcheck today tracks throughout the show. with all the different settings you have. And I suppose even that's a great way. Sound check. There's nobody in this sports arena. It's a little live. We can pull that down 3 or 4 dB, and we get there and we go, oh, it sucked up the energy. We can just push that one fader and know that the next recall of the next scene, it'll track in that correctly, and it won't jump because there was a change of a preset. And I suppose that's, Scott, I think from the sound designer standpoint, the mix engineer, that's probably step one to adjusting the space. It's really quick, really fast. You might get into individual settings after that and decide, ooh, our large hall sound is too large. We need to play with that today. But it's at least step one.
Yeah. Or sound check sounded great. Now there's 10,000 people in here.
Oops.
Where's all my reverb gone?
Yeah. Why is the room sucked up? Yeah, exactly. Now, the preset options, Sylvain, there's 37 presets, and they're all a good start. Have you found in your use of this for the last many months that there are some first things you adjust when you play with a room sound? Like, what's your order of operation for adjusting one of the sounds? Do you have a specific one?
Yeah, so maybe first to adjust the sound, you will pick up the right preset, and for that we have put this audition button so that when you are...
Yeah, do you want to show that real quick again?
Yeah.
I hope the pop-up will be shared as well.
Great, yes. Perfect.
Cool. Okay. So the first thing to do would be to enable the audition button so that everything that is currently going through the processor would be played through the reverb that you have selected in the wizard. So let's say here I want to listen to a theater medium warm. Just because it's selected here, I'm already listening to the result. And if I have selected a combination of colors, for instance, medium bright, even if I'm trying to listen to a different venue type, that will keep the same colors and the same characteristics. So I can really listen very quickly to the different results. So it's the first step to adjust my reverb. Once I have found the one that I want to load, I simply load it in the interface, and then the first thing that we'll do would be to adjust the virtual room size. It's really the main tool. We have even set some dependence of this button, let's say the onset and the decay time, which are normally different parameters. They are by default linked to the virtual room size. So the first move would be to adjust the virtual room size to get the perception of the volume that you want to have. So it will have an influence on the cluster and on the late reverb as well. And once it's done, I would start maybe to adjust the late, because I'm maybe more sensitive to the late than the other reflections, but it's probably just for me. And I would start to adjust the tonality of the reverb. So we will have the general tonality with the filters, the simple HPF and LPF.
Do you want to bring up the yeah, there you go, the EQ.
Yeah, it's here. So I would simply adjust the way the entire reverb is colored by the EQ. And then I would start to adjust how fast the high frequencies are decaying over time with the decay ratio. So maybe the best view is here. So we have split in that view the different parts of the reverb. So we have one line for the early, one for the cluster, one for the late. And it's representing the time duration of each block. And you can see that the decay, the late decay has two colors. That's because we differentiate the length of the low frequencies versus the length of the high frequencies. We have a control that enable us to shorten the length of the high frequencies if we want. And it's a very powerful tool, because it's the main way for a late response to really not emulate or to represent the response of a room with in the late aspect. So even on the EQ section, we can see that we have this main slug here, which is the absolute EQ of the entire reverb, and we have a small line which is clearer, and this line represents how the reverb sounds. Can you confirm, Fred? It's half time of the decay?
Half the decay time.
Yeah, so at half the decay time, we can see that the reverb will already sound darker. So we can see if we have a full decay ratio, so no difference between the low frequency and the high frequency, we can see that the reverb will sound the same half decay time, but we can make it sound darker, and we can change the pivot frequency, the corner frequency, where this drop of high frequency start to occur. And then the other parameters, which are pre-delay, diffusion, it's a bit more familiar, and I will start to tweak these parameters. Then the gain shaping as well. All these space parameters, which are a bit different than a normal reverb, but I would not go for them at start. I would go for really the room size, the color, and then the space response.
Yeah, and these are kind of the more complex aspects of a spatial room engine, right? So gain shaping and delay shaping, we can amplify or exaggerate, Fred? Is that the right way to say it? The response based on the object position. So if I have an object on one side of the room, I can amplify the delay coming from the back. Is that maybe the way to say it?
Yeah, absolutely. Those controls, delay and gain shaping, are relative to the source position. So yeah, indeed, we are zooming, we're expanding the way the delay will propagate to distribute the late in space. And so that's for the delay part, which gives some very interesting effect. And there we can even create like unnatural things if we really go the other way around. And the gain shaping is here we're just shaping, but more in a static way. We're shaping how the energy is distributed, again, relative to where the source is. And that's also quite a powerful tool.
So if I have two actors in a scene I'm thinking of, we could somehow do something interesting and shape the delay or the gain opposite each of them. So as one is talking on one side, it would be exaggerated one way, and one is talking the other way, it'd be exaggerated. That might sound great.
Yeah.
Or it might not. Yeah, exactly. As Scott, you said, I think we have to experiment and lock ourselves in a room for hours and days on end to find out what is the tool that will tell the story we want.
Yeah.
But it does link to, I think, the beginning of the whole conversation about the difference between a reverb and a room engine. Because indeed, we can go, because of that kind of special information, we can go beyond what we could be doing with just a plain reverb. And those are very good examples in terms of delay shaping in space. This is really crazy and interesting tool. And the other element that I thought since then is also that we also pay great attention to the position, the distance element to a source. This is something also that is an important control you have on a soundscape in the ELISA controller. And that's here, indeed, we see in the interface right now how the gains of the different parts, the early, cluster, and late, how they behave with distance. And that, of course, plays a very important role on how it feels like a natural way of it's a propagation time and levels depending on the distance. Let's say how the cluster, and we see the cluster and the early, their level reduce at certain rate with distance, whereas the late has typically very different behavior.
Oh, interesting. So this graph, we're actually seeing there's a blue line, and that represents as I move an object backwards in the soundscape, it's attenuating the object, right?
Mm-hmm, mm-hmm.
And then each of those three components, the early, cluster, and late, are mapped on there in thin, thick, and solid line, thin dotted, thick dotted, and solid line. So as you push that object further and further back, it actually engages more and more of the late portion of the engine. So it's not like it's just a perfectly linear relationship in on-off aux. It's actually changing the drive to each of these components as you move that object forward and back in space, which is really
absolutely
really quite interesting. Oh wow, that's
So I think the interesting part here, I find that in some way, if we want it to be like super, in a way, maybe rigorous or following the textbook, we could say the late reverberation should be at a constant level, because typically that's how it's described in acoustics. But however, we also have to keep in mind that often we want also to create a certain effect, and we want to amplify an effect. And therefore to have this very granular control over the levels of the late for the early part, the late part of large distance, the far part, helps really to emphasize certain effects, basically. So well, that's...
And as you were talking, Sylvain just switched it to that textbook style, right? So late energy is stable and consistent, and the early and cluster are attenuating along with the original object. So that could be that textbook style versus giving Scott and all the other sound designers around the world a lot of freedom to try out many different things to see what's the right thing for their particular show.
Yeah, and I think we can also... What's interesting also, we can create a very much a proximity effect with the line arrays that we have typically deployed in our layouts. So therefore, we can even go beyond what would be naturally the zero distance, really. So when we start to have, let's say, no room engine activated, like here, with this fading in particular, then the source snapped on a speaker really at zero distance would appear actually closer to where the speaker is. So it gives a lot of flexibility.
Yeah, Scott, I imagine in a storytelling moment in a show, what Fred was just saying, we can actually use that proximity effect to almost make a narrator come like out of the show, right? Step past that fourth wall.
Yeah, it's powerful. Also, in that with all of this immersive audio and the enthusiasm that come from the musical directors, composers, and sound designers, we end up with a lot of thickness going on within the soundscape. Very powerful tool to be able to maintain intelligibility and clarity, while still having a really interesting and complex bit of content going on at the same time. But previously, our only tool was amplitude. This is really powerful alternative to that.
Yeah, that's really interesting. So, Fred, you kind of swung us all around full circle here, which is great. Does anyone have anything to close with like that? What's the thing you're looking forward to, Scott? What's the next big thing you're looking forward to using this room engine with, or Eliza, or audio in general? Anything exciting coming up?
Expo is the big one at the moment. There is another one after that isn't really something we can talk about just yet, but soon we can, and that's even more interesting topic, especially for the room engine. But Expo is pretty exciting. There's a lot of sound designers starting to create content right now, all shortly once we've rolled it out properly, making use of Elisa Studio so they can have a bit of an understanding of what a 130 meter dome with 27 loudspeaker arrays, sort of what that does when you place a probe off center and listen to an orchestra spread out over way too many loudspeakers and hear it all tear apart in the time domain and then put it all back together again. And yeah, so I'm pretty excited to see a lot of the stuff we've been talking about for the last 2 years start to turn into audiences really enjoying an environment that's, so in terms of immersive audio, it's one of the more exciting things I've been involved in.
And Scott, that is the most perfect segue possible. So everyone who joined us this week, the next episode, we're actually talking about scale simulation, which is a brand new feature in Elisa Studio and Elisa 2.2. We're going to have a few friends from Alt-J join us to talk about the challenge of immersive audio in a space. It was still large. It wasn't as large as 130 meters, but it was about 80 meters front to back and 60 meters side to side, which in music poses an interesting challenge that, once again, I think, Fred, as you were pointing out earlier, physics has laws, and so we can't defy the speed of sound. And we have to think about that from a music standpoint, from a programming standpoint. So thanks for that segue, Scott. I appreciate that.
Pleasure.
Yeah. Fred, anything for you? Room engine, do we imagine that we're going to add another 500 features or variables? Where are algorithms going these days? What's the exciting thing?
Yeah, I mean, of course, we are working a few releases ahead, and unfortunately, I cannot say too much. But let's say it's still a very important topic, and I think there's still a lot we can do in how to make sure we deliver a message in the proper way, regardless of the size, of the scaling, of the type of audience, of the acoustics. So there we still have quite a few things, planned in the pipeline. So very interesting things to come for the room engine. And yeah, in 3D also developments that will be, I think, important.
Excellent. Sylvain, do we have any more presets? Is there a 38th or 39th preset that'll come out soon?
Yeah, it's up to the users. I hope that that most of them will find their way in the interface and create some very interesting presets. We are really looking forward to hearing the feeling of the users about that reverb, because we really worked hard on it, and we have explained mostly the technical part, but we have paid specific attention about the simple quality of it, which could not maybe so obvious when we are only speaking about dimension, scaling, and time arrival, but just the pure sound of a single channel of reverb. We have worked a lot, really hard on that. So I hope people will feel that it was
worth it. Yeah.
Yeah.
Absolutely. I have no doubt of that. Everyone, I want to thank you for your time today. Scott from Hotel Room, and Fred and Sylvain from London. Thank you guys for joining us today. For everyone at home, if you have any questions, please don't hesitate to reach out to us. Social media, obviously, all over the internet. You can find all of us. Thank you, everyone, for joining me today. And thanks for the conversation. And we'll see you soon.
Thanks, guys.
Thanks, Scott.
Bye.
Bye, everyone.
Bye.